Increasing your IP value by adding prototypes and experimental work to what you do. Hello and welcome back to Invent Anything. This is John Cronin. This episode is going to cover a little bit of history. In the 1790s, for instance, you needed a working model to get a patent. Today, that's not true. But it turns out that prototypes have had their value in the patent system in many different forms, and today it's changing again. As we start to look at AI and large language models and all the rest, prototypes and experimental work can really change the value of intellectual property. So we're going to talk about all of that.
Inventions keep the world spinning. From fire and the wheel to today's high tech, inventions power change. Turn your inventions into reality. Learn how to get your ideas to market. This is Invent Anything with John Cronin.
Today we're going to cover 6 topics. The first topic is when you look at patents, can you have prototypes or lab work help? In topic number 2, we're going to talk about instantaneous prototypes and lab work in our new world of AI. Then we're going to move to topic number 3, which is going to talk about prototypes and lab work, whether you should do it before or during or after the patent process. In topic number 4, we'll talk about 10 ways to add value to the patents from prototypes or lab work. In topic number 5, we're going to talk about strategies for patents with these enhanced prototypes or lab work. And then topic number 6, we're going to have a little fun as we talk about the future, sort of the next phase, where AI virtualization of the physical world goes to the digital world, and now the digital world can go back to the physical world, and how all that all can be connected. You know, usually when we talk, I start thinking about the audience, and I think there's different audiences for this podcast. First of all, for novices, I think unfamiliar with the prototypes in the patent system, this primer will help demystify the requirements of what you need for patents, but also help you understand AI's new role. For small companies that seek sort of basics on lab work and filing patents and starting the prototype journey, this is for you. You may find that you have a prototype and you're thinking about patents, but you may find that you're only thinking about patents. So now we may want to talk about how prototypes can help. For larger firms, we can identify gaps and provide some sophisticated tactics for AI-enhanced prototyping to add value to your portfolio. For managers and supervisors, we want to give you kind of a briefing on the timing of prototypes and when actually to go after a prototype in the patent process. But for some audiences, like those exploring the links between prototypes and AI, now we can add this IP discussion to it. And finally, for those people maybe as an audience, starting your journey, this could introduce you to hundreds of new ways of thinking about using AI in the patent process. So this is John Cronin from Invent Anything, and coming up, we're going to examine the evolution of the patent system, dispelling some myths about mandatory prototypes and lab work, while addressing variations in global practices. And we're going to follow up with exploring how AI transformation's role in prototyping has changed dramatically, from rapid virtual iterations to collaborative agents that run streamlined innovation processes. I'm actually a practitioner. As an inventor, I'm constantly now working on AI agents in prototyping. So I can not only talk as a CEO, but I can also talk as an inventor who's actively using these. So stay tuned. So let's jump into topic number one. Don't patents, as a form of intellectual property, always need prototypes or lab works? I talked about earlier that in the 1790s, the Patent Office required physical prototypes, and they had to show their inventions to the inventor board, the patent board. But that's not true anymore. In the 1880s, one of the buildings burnt down with the prototypes, so they decided to change the laws so you didn't no longer require a prototype. So there's been a lot of sort of myths where people thought you needed a working model. Many believed that a working prototype was required to get a patent. You don't need a working model to get a patent. You don't need the app running. The only thing you need to know how to do is explain how it works. The U.S. Patent Office, as I mentioned, burned. And so what happened is that was one of the drivers to no longer need a prototype. Could you imagine all the millions of patents in the Patent Office all having a prototype being stored someplace? So they stopped that. But there is some places where the Patent Office could require sort of a physical check on whether your inventions work or not. Certainly in chemical formulations is one area whereby the patent office may actually ask you for data on how it works. But 99% of patents today don't need anything like that. There could be some new discoveries that the patent office may actually ask you to prove, but that's also very rare. One of the things is that when you take a look at the patent office across the globe, certain countries have different regulations. For instance, in Japan, they may demand more evidence of functionality than in other countries. Big companies get an advantage here because big companies can leverage their dollars and cents, if you will, with their large R&D labs. Large firms with labs can gain advantages because they can back up their inventors with working prototypes. So they may actually know more about the invention than a solo inventor. So tech giants like IBM can test prototypes in-house, while that lone inventor would really struggle to even afford the equipment to test it. And so that's a difference in the patent system that if prototypes are required, of course, the larger companies would win. So for chemical formulations and discoveries in those types of inventions, large companies may actually win to be able to get more patents. But in general, it's really not an issue. One of the things that's really true is that domain knowledge really drives the ability to enable. So inventors with deep technical experience can secure more patents than those that are just sort of getting started. A car engineer who understands how engines work is far more able to enable inventions and get them through the patent office than someone sort of dreaming about some improvement to an engine who can't really enable it. Although what happens is that software changed the game for patents because software kind of widens the inventor pool, meaning that really, if you can write a flowchart down about a method, that method can be done pretty easily in software today. So really, there's much more inventors in sort of a software space than there is on special hardware. And so that's kind of another driver here. The patent system has kind of provided a large value to those people that can enable software, especially in today's day and age where the AI helps you write the software. One of the things that's kind of interesting is you get a little bit older, you find out that you have more wisdom and more knowledge. Well, it's also true in the patent system. Research shows that inventors, the average age of an inventor is more 47 and over. So that means their know-how, their years of experience has really helped them gain the know-how of how to do things so they can get patents. Another thing that sort of happens is that you can obfuscate your trade secrets. So when you develop a patent, you need to provide your sort of best mode. But if you can enable things on paper and pencil without building the prototype, you can get the patent through, and then maybe later on in the prototyping process, you create your best mode. So sophisticated inventors might file inventions at the paper level, meaning they know prototype, but later on, come up with the prototype to actually learn more and keep the sort of the trade secrets to themselves. It's kind of interesting history. There's a lot more to that, but for this podcast, I just want to run by some of those concepts. Let's jump to topic number two: instantaneous prototypes and lab work in our new world of AI. Boy, things have changed. In this new world, prototypes before the AI era, well, it would take time. You'd go to your bench, you'd build it, you'd do a physical build. In say 1980, you'd take a circuit designer and he'd actually breadboard the circuit to see how it works. Well, today you can take a design in a computer, and the computer can actually help you analyze the design, show you waveforms. And so literally in hours, you can see if the circuit works versus building the prototype without ordering the parts. So the idea of AI even helps that even more because you could just ask the AI to build me a circuit that does this function, and it will start laying out the circuit. Another thing is that large language models have enabled rapid prototyping as well. So you could take, like in 2022, when large language models started, you can create almost detailed designs instantly. An inventor can use large language models to draft new gadget blueprints in minutes and sit there and iterate with it just by asking the large language model AI to do another rendition and another rendition. So now you're using the AI large language model as a laboratory. Another thing that happens as we start thinking about instantaneous prototypes and lab work is that AI can test multiple variations. You can ask the AI, what would this look like if I modified the handle? What would this look like if I decided to add this added functionality? And you might, like a baker could tweak a virtual oven and perfect it in AI by running 20 different simulations before they got the temperature profile right. It's really amazing. Another thing about instantaneous prototypes and instantaneous lab work, and I'll talk about lab works in a minute, is that you can do virtual experiments and fill up data tables. So literally in AI, you could say, I'd like to take my particular invention and break it into a table of like 4 inputs and 5 outputs. And you can tell the AI to run, you know, run a process to fill out the table to give you examples. So it might provide 3 or 4 different inputs, a temperature, a voltage, a moisture level, etc. And then it would output, the things on the output that might be the actual measurements where you might be measuring certain things in the device. So AI can generate the data tables. Another thing about instantaneous prototypes is that AI can actually identify novel data. I didn't believe this until I did it myself. You could sit back and ask the AI to go out and read 20 different scientific experiments in some papers you give it, and really say, is there some place in these papers that people haven't really studied yet? It will then tell you that area. And then you can work with AI, say, well, run me an experiment to do that. And let's just see the answer. If the answer comes positive, now you've got a virtual invention that you can then file a patent on just by sitting in front of a large language model. You can concoct a scenario, read papers, find if there's a novel area in the papers that haven't been disclosed, and then run and try to create that experiment and then file the patent on it. Truly amazing. Another thing is that the AI allows for multimodal prototypes, meaning audio, visual, etc. So the AI can generate text, generate 3D renderings, generate videos. And so now an engineer could submit a 3D rendering really easy. So supposing you would develop a drone, you could actually get a really great picture of the drone to submit in your patent without actually doing the work, just having the AI help you do that. Another area for sort of instantaneous prototypes and lab works is these AI agents collaborate with each other now. So one AI can call another AI to run experiments, and then that AI can then figure out what's novel, and that AI can feed back to run even more experiments. So an inventor's set of prompts can simulate, say, a robot arm, design it, check its uniqueness, and iterate it over and over again until it got it right. Another area where instantaneous prototypes and lab work come is that AI can be rapidly advancing here. Today is 2025 in September, but within a couple years, you may eliminate totally the engineering needed to design almost anything. And we're going to have super intelligence coming. So I'm talking about something that's happening today, but the interesting thing is almost every day goes by, there's more capability. So we will instantaneous prototypes and lab works actually get to. The other thing about instantaneous prototypes and lab work is that it turns out these AI subscriptions are low cost. I mean, you can get a ChatGPT for $25, $30 a month, a Grok for $20, $30 a month. It's likely that you'll have multiple subscriptions to multiple types of AI. For instance, a ChatGPT is really very, very good at searching text and finding patterns, whereas a Grok is really very good at scientific knowledge. I mean, certainly you can use both for both, but there's certainly ones that are best for the job to be done. So another area where instantaneous prototypes and lab work kind of work in the world is that these things are incredibly low cost. You can get an AI subscription for $10 or $20 a month. Uh, but I've also found that some large language models are different. So you might be able to use a chat GPT for $30 a month because it's very good at searching text and sort of combining text together to find new ideas. Whereas Grok, I think, is a much better AI for scientific endeavors to actually have discussions on a more scientific level. Although I know both can do both, I think some AIs are much better at one thing than another. So today, in fact, I have 6 different AIs that I run almost every day. By the end of this year, I'll probably have 25 of them. So if you just think that ChatGPT or one AI is what you need, you're wrong, because in the future, you're going to have multiple ones. Finally, another area that instantaneous prototypes and lab work hit our world is crowdsourcing enhances AI prototypes, meaning that the AI prototype can integrate with other experts, which you can then hire in platforms to do some work. So the combination of an AI with large language models with the crowd is very, very powerful. So coming up in the upcoming sections, we're going to analyze the strategic timing of prototypes and lab work relative to patent filings. And we're going to talk about uh, prototypes and experimental work, whether you do it before or during or after the patent filing. And then after that, we're going to talk about 10 methods for leveraging prototypes and experimental lab work to augment patent value data. So it should be really interesting. And I want to make sure that we spend the time to use these 10 methods, but just to give you examples, because there's many more methods than the 10 we're going to talk about. So let's jump into topic number 3. Um, Prototypes and lab work before the patent or after the patent. Now, once again, I'm talking about prototypes and lab work, and I just want to be very clear about this. You can create prototypes, on the bench, but now today you can use AI to help you develop the prototype virtually. You can create the circuit, you can create an engineering drawing, you can literally build the prototype virtually by just prompts. But also, you might not know unless you play with this a lot or do it. You can also use the AI large language models to create the data, to create the charts and the graphs that you might do when you're doing experiments. So, experimental lab work or prototypes are really the same thing now. You can do them both virtually. So, as we start talking about prototypes and lab work, we just want to sort of recognize that you can create a prototype virtually and the experimental work virtually. That's really cool. So let's get into it. For the first thing is that we can use prototypes to refine the claims. So before you file patents, prototypes can help, and these are virtual prototypes, by the way. You can build real prototypes if you want, they just take longer. But prototypes give you information about enablement, and that will help you build much better claims. So it's really good if you want to build strong filings. So let's go back to our baker, and he's testing his oven design before he files the patent. So now he finds out about the specific wavelengths of the energy and the time, so he could put those in to the patent, showing much better depth. So it used to be you just come up with the paper patent and write the patent on how the oven's going to be built, etc. But now for a couple more hours, you just virtually create the prototype in the experimental data, and you can pack that into the specification and build much better claims. It's just amazing. Another thing we can do here is we can perfect uh, the things that you might have had risks on before. You know, before you might try to build a prototype and wait till you got the data until you filed the patent. But you might risk losing the patent because you're late to the patent office. I think Alexander Graham Bell's patent on the intermittent switch for the phone, he filed it about an hour right before a competitor filed the same patent. So he would have been a much more different world if he didn't need to wait for the prototype to, figure out what he needed. So what's really interesting about this example is that uh, you can get a lot of patent value out now because you can do the prototypes virtually. You don't have to wait until the physical prototype is built to get the data. Another area about prototypes and lab work before the patent or after the patent is, um, you could take a look at the claim breadth and recognize that your funding could be limiting here. In other words, before the filing, you might have a limited R&D funds, and therefore you might not be able to do as much. So you might not be able to claim as much. But now with virtual prototypes, you can get all that done for very low cost. So that garage inventor that might have had a tight budget, building some simple robot arm or something, now he doesn't have that tight budget because he can develop all the prototypes virtually for an account on Grok or ChatGPT. So now you don't have to limit your claim breadth. So and funding won't limit you, for the prototype. Another area is that you can build really an experimentally rich specification. So before you file the patent, you use the prototyping virtualization to create all sorts of data tables and charts and graphs that basically are virtualizations of physical work. And so the scientist can probably test his drug formulations and extensively do that and come up with data that he can put in the patent specification that then allows him to have a very robust patent filing. Another thing is that failures many times would create patents that were a waste because you based, the patent filing on sort of thinking about how your invention would work. But now with creating a prototype really quickly, you might find that your prototype doesn't work, and therefore you wouldn't file the patent. So you wouldn't be wasting money. Another thing about sort of prototypes being created virtually in patents is that you could develop prototypes after you file, right? And that will enable you to sort of help you sell the patent because you have a real virtualization of a prototype on the patent. But very likely, if you filed a patent and then you decide now, because of listening to this podcast, you want to build a prototype, you may find in building a prototype that there's 2 or 3 new patents that you want to get because you've learned from the prototype more about your invention. Another thing is that, you can do a whole bunch of things when you kind of deal with this sort of best mode requirement. The patent system says that at the time that you file your patent, you need to include your best mode, the best way you think it works. Well, now with prototyping with AI, you can play with that a little bit. You can file the patent first and then do the prototyping second in AI to find the best mode. If you're a beverage firm, you're trying to create a new superior drink stabilizer, you can kind of concoct what you think in your specification, but then very quickly you can run experiments, virtually to figure out how it might work better. And sometimes you could do prototyping first, enough to get the paper patent and be really smart about it, and then do prototyping right after that to get the best mode. So you can use virtualization now to sort of get your patents, but have your cake and eat it too, with having trade secrets even, or patenting the prototype and then maintaining the best mode as a trade secret. Another area that prototypes and lab work intersect with the timing of patent filing is you can basically After you file the patent, you can get a prototype, and then the prototype can be marketed to help you roll out the invention to improve the market value. So if you kind of patent a smartwatch concept, then you can create a prototype even virtually and showing the design for sort of a marketing launch. So the IP covers what the successful product later will be. And so understanding how to announce results of a prototype based upon when the patent filed is really key and could save a lot of money because you don't have to build a prototype first, then file the patent, and then market it. Here you file the patent, get comfortable with that, and then virtualize the prototype and market that. Another area is that um, the prototype really can give you a lot of information about how much you can expand the patent and how effective it's going to be. So after filing, the prototypes can verify if the product really would work. And then so you can build like a bike lock for a prototype. One of the things about prototypes and the virtualization of prototypes is you can really confirm the effectiveness of the patent. So after filing, your prototypes can be built virtually and verify if the product elements actually work right. So if if you can verify that, then you'd be more apt to spend the time marketing the patent. Sometimes if you patent something and you really don't know how it works, you could find out from others about some of the problems with your patent and then waste time trying to market your patent. So supposing you built a bike lock and got a patent on it, but then you prototype it, and then you realize you sort of omitted some key feature about how to store the key or how to, ensure the lock really worked. It would be great to know that before you try to market the patent. So if you're thinking about marketing patents where you don't have the prototype, now with virtualized AI and experimental work, you can do that. So let's move to topic number 4. I promised sort of 10 ways that you can add value to the patents from prototypes. And the first one is that because you can create charts and graphs virtually of almost any invention, you can now use that to strengthen enablement. So you can add data charts or tables to, to strengthen the invention disclosure. So if you create a solar panel, for instance, you could use the prototyping in AI to find sort of charts and graphs on efficiency, for instance. And a picture of the solar cell or a cross section and some experimental data through some tables really adds a lot of lift to the specification. As they say, one picture is worth 1,000 words, right? And this is true of patents. A chart or a graph can add a lot of different examples without saying much in the English language because the data table can be thought about many different ways. So many times adding charts and graphs and pictures about your invention will help you have a lot more subject matter in the patent. Another thing that I have found as an inventor, and over the years I've aggregated about 2,000 patents myself, is that images really help in a patent to have sort of reality when you're talking to the examiners or buyers. So if you have photos, for instance, of the drone that you're talking about in your patent, and maybe have some simulations of it pre-flight, that would really help in trying to sell the patent or would even help in discussing with the examiner your invention. So once again, this idea of AI-based prototypes or lab work can really help improve the value of the patent. Another thing that's certainly true is that if you can use AI to develop the prototypes before the patent files, and you use all that data in the patent specification, then you have a robust patent specification. And what that means is when the patent issues, before it issues, you're allowed to get a continuation. But you can keep continuations going and get many patents from one patent by having many continuations. So prototypes help build that specification. Uh, Another thing about prototyping is that it inspires new claims. So by developing a prototype for your invention before you file the patent, you can actually then come up with lots of different insights that you can then lead to, all sorts of new extensions to claims. Another thing I mentioned is that you do this experimental work. So you could come up with all sorts of patent claims that are based upon testing. So supposing you have an invention, but you do a prototype, and in the prototype, you kind of test sort of measurements. For instance, supposing you are designing a fabric, and you could take that fabric design and put it in a patent, of course. But supposing if you were to develop the fabric in a prototype, in a model, in a chat language, you could then ask the chat language what you could do to test it, and it could suggest some sort of strength test. You might be able to then get the AI to do the strength test and give you data, experimental data. You then could take that experimental data and put it back in the patent. So now the patent's not only going to have the structure of the fabrics, but functional results of how strong the fabric is. So now we've got a great patent, right? Because it has not only the structure of the fabric, but the test results of it. It's just mind-blowing what this AI can do. Another thing is that we can do testing to support functional claims. So the lab work basically is done to figure out the functionality of your invention. So supposing you have some sort of car that you're building or some sort of drone that you're building. And basically, once again, we use the AI to build the drone in a virtual world. But then you can, in the virtual world, put it in a wind tunnel, a virtual wind tunnel. And now you find out that your drone can withstand certain speeds uh, at high at high velocity drive or something. Now you functionally know that you have something that you wouldn't have known if you hadn't done that experiment. So now we can file the patent of the drone the same way, but now we can use the experimental wind tunnel data and get functional claims. So just like before we could get testing claims on the fabric structure, here we can get functional claims on the tests that you did virtually. I did talk about best modes a couple times, but just to reiterate, if you could build a patent and then find the best way to do it with the prototype, you can find your best mode. So it could be that your best mode you put in your patent because you can go through 20 scenarios with AI, finding the best scenario for the best mode, and really put your best mode in the patent. And that might be very useful because you might want to claim specifically the specifics around your best mode. One of the cool things is that when you can do virtualized prototypes or experimental work, you're bringing in the value chain. And so you can have sort of patents that could cover off not just what you're building, but also what your supplier might do if you actually try to build the product. So, for instance, supposing there's some sub-assembly that when you are building your prototype that you would find you'd need, and that sub-assembly comes from a supplier. Well, now we have the ability to do that virtually, and so we can include those improvements in the patent to cover the supplier's inventions. One of the things about adding value in terms of some ways to do that, some tricks, if you will, is a lot of times the prototypes give you surprises. I can't tell you, working for clients even the last 6 months, helping them design, you know, patents to file, but doing prototypes with AI, that the prototypes are giving me surprising results. And those surprising results might be something I want to put in the patent. So you could do some sort of lab experiment of a glue formula, do it virtually, and find out you get some exceptional adhesion to different materials that you didn't think you could do. So now we can put that in the patent, and that's a surprise. And now have claims for your glue being able to use for different materials that you didn't know of. Just by simply asking these questions in the AI model, you can add them back into the patent. And finally, a 10th little trick here is, and it's a little bit esoteric, but many times patents get rejected for different reasons. One would be a 101 rejection because your invention is abstract, or 102 rejection because there was an identical invention to yours, or 103, which is an obviousness rejection when you're combining references. But if I go back to this abstract rejection, if you build a prototype in AI and you really make it work, it can't be abstract anymore because you showed its operation. So this is really cool. Those are 10 tricks that we could use to really get a lot more value out of the patents where AI prototyping or AI-based lab work help. Coming up, we're going to come up with our third section here, which is to explore strategies for enhancing patent values through advanced prototyping and lab work, from facilitating provisional sales to expanding claims versus continuations. And then we're going to follow this up with the final kind of study on how AI virtualizations that you're doing, which you've done in the virtual world, will then start to define what the physical world is going to look like, which then is going to allow you to go back to the virtual world. So we're going to learn about how AI can create the physical world, and then how AI can help us take the physical world back to the virtual world, and talk about patent claims for that whole process. So stay tuned. Let's get into topic number 5, strategies for patents with enhanced prototype lab work. So one thing is for sure, and that is when you're trying to sell a patent or license it, having prototypes certainly help. And so this is exactly what the new AIs can be used for. Any patent that you're trying to sell a license right now, go back to the AI prototyping and build a prototype around the patent. And the value of that patent is going to be much higher. You can take that little trick to the bank. A second thing is we talked about continuations. For those people that are novices here, when you file a patent, if the patent office is going to allow it to be issued, right before you issue, you can file a continuation of another invention within that patent. Well, if you don't have specification to cover more invention, you can't do a continuation. But the new trick is with doing VAI, you can expand the specification before the patent filing and have multiple continuations. So this is a wonderful trick or a strategy for enhancing the value of the patent using prototyping. A third one is it's a strategy here for enhancing the prototypes of lab work for patents is to publish to attract partners. One of the cool things is that you can take your patent, create the prototype, and now what happens is we can share that prototype in marketing or in some sort of PR announcement. So you can share it without losing the rights because you have the patent. So if you're really big on developing prototypes with AI, you want to go backwards to make sure you get patents because you can share it not losing your rights. We tend to get a lot of inventors calling us today because they have created prototypes in AI and they're trying to market and sell them, and they get to thinking that they don't want to have somebody copy them. And so patents are the way to do that. So if you're a biotech firm, for instance, that publishes your lab findings on some new enzyme, um, and you want to draw investors in to take a look at that, filing a patent first is a way to protect someone from copying it, which then leads to kind of startup opportunities. Um, what happens here is you can enhance prototypes to create businesses like any startup. And so, supposing you built some sort of eco-friendly bottle and a prototype on crowdfunding, and you're looking for partners. Well, patenting that eco-friendly bottle concept is really important so you don't get copied. So for startups, this is a wonderful opportunity because you might create a startup based on the patent, or you might create the startup based on the prototype. But now, in fact, the combination becomes a lot more powerful. And I don't care which way you want to do it. Develop the product first, the patent second, as long as it's within the time window. develop the virtual product first, the patent second, or the patent first now, and the virtual prototype second. So that combination allows you to start a business. And once again, the AI prototyping and experimental lab work is really inexpensive. So maybe by listening to this podcast so far, if you haven't done it, you might take a note that you maybe this week you're going to go off and experiment with AI to see how you can start using it to develop prototypes for experimental lab work. Another strategy for patents to enhance the prototype lab work is to do the prototyping in a virtual way to really help convince the examiner that your invention really works. And so this is really kind of cool, which then leads to the fact that as you're working with examiners in office actions, you can literally take what you're working on, put it into the AI, create working models, and show the examiner. So you can literally answer examiners' questions with AI results. Another area is that you can now submit multimedia to examiners. And so AI can be the rendering of your invention. So supposing, you're trying to submit an invention and get it through the patent office with a robotic arm, and you have some simple mechanical things that move the arm in very unique ways. Sometimes getting that concept across to an examiner is difficult. Now you can make a real-time movie of it and submit it to the examiner. Another sort of real-world experience here is that real world is now the virtual world. And so by submitting virtual world renditions of graphics or audio or any kind of model can be used as a way to enhance the patent and your ability to get the patent through. So supposing you're testing a fitness tracker, and when you do a prototype, you can now recognize that the fitness tracker may be able to add another sensor to essentially help the user be more efficient in using your fitness tracker. Now you can do this in the virtual world and add this to your patent. And I see a lot of inventions where the inventors will, supply a sensor to do something, and that's their invention. But now with AI, you can create multiple sensors and test them all virtually and put those in the patent application. One of the things is that prototypes really allow you to look at the physical risks and the workarounds. So if I go to like a solar charger and I want to see how durable it's going to be over time in real conditions, I can now virtualize experiments to see the longevity of my charger in terms of the experiments that you might do on the bench, that you could run through the circuit variations and see the longevity. So one of the things is that you can sort of value the risk of your invention before you file the patent or even build a prototype. In other words, do longevity studies with AI, and do it in 20 minutes and not have to wait for lots of experimental tests. Now, I'll say everything with a grain of sand because I'm making it sound like AI can do pretty much anything, and it can. Trusting the results is a whole other area, and sometimes AI hallucinates and gives you wrong answers. But I have found over even the last year that the more I know about how to write prompts to make sure I can eliminate hallucinations, tells me to feel more confident that you can do this pretty soundly. And a year from now, it's going to be even better and better. So AI in a year from now probably won't hallucinate anymore. Another thing is that you can demonstrate the scalability of your invention. You can literally take your invention and basically, like, suppose you had some sort of water purifier prototype and you had a laboratory, you might be able to then say, I want to scale this water purification system up. And in doing so, with the AI, you might be able to develop the manufacturing process to make that water purification system, to scale it up. And then you find out that there are inventions in the manufacturing process. So now we're using AI to help us think about scaling up. Previously, we were using AI to help us figure out longevity. We're using AI to think about risk. It can be used for a lot of different things. And finally, you can use AI for simulations for anything. AI can simulate sort of a brake system where you're lightening the weight of the materials on the braking system to find where the braking systems might not work. You can simulate all that and then get patents on the place where you can have just enough material that it won't break in use, and and therefore have some wonderful inventions on real life applications. So let's get into our final topic, topic number 6, the next phase: AI virtualizations of the physical to the virtual and back again. This may sound a little bit out there. Um, I just talked to a client today about this concept and got the okay to engage on actually doing this for a client. I have done this in some examples for other clients, but this is conceptual as well for you. Uh, but I just want to use this section to talk about really where the future heads. So this is sort of the next phase, how AI's virtualization allows you to go from the physical world to the virtual world. In other words, I have something physically working. I can model it in the AI and see how it should work in the AI space, but then I can use those improvements to come back to the physical world. So one thing is that AI guides physical learning. AI can generate code or a 3D model so that you can literally directly create prototypes. Um, and here is sort of something you're seeing with all these AI experts. AI is coming up with concepts. And people are saying that the only real way that we're going to know if those concepts are going to work is to put them in the physical world. Sort of think about that. AI is developing prototypes and simulations. Well, you could assume they're going to work, but some of these things really need to be built. And so they're saying the physical world is where the truth is, and the virtual world is where the conceptual stuff is. You could kind of agree that an AI in the virtual world is going to work, but unless you really put it in the physical world, you won't know that. So the key here is that truth testing is in the real world. The concept is, can we build a virtualization from the computer that spits out data, but that data is actually driving a physical thing, and the physical thing is moving based upon the AI data, but then the physical thing is moving or doing something, and it has sensors on it, which is data, which can feed back to the AI. So the AI can literally send data to the physical device. The physical device does something, and then whatever it's doing can be measured with data that goes back to the AI. And the AI uses that information to change its input, to look at its own output, to then change it again. So now the AI is providing the input, measuring the output, but now the AI is connected to the physical world where truth is. This is a big concept because what happens here now is this is the reason why we start to think about robots, because robots can do things physically. AI is doing things sort of virtually. But what happens when you take AI and use it to drive the robot, and the robot goes out and does the physical work to find out what truth is, to send it back to the AI? So this concept is not very strange at all. And if we sort of think through it, this is where it's headed. But even more importantly, when we think through this, what a wonderful thing to start doing in a small fashion to help us improve the patent process. So one of the things is there's this sort of idea of the physical RAG learning loop. So RAG is a term that's called, retrieval augmented generation. It's kind of like you have a thought, you can check it out, but there's a corpus of information, a set of papers where there's a lot of data. So if you supply the data with what you know, this sort of retrieval of this augmented information can help you generate better. So now AI can run in real time on devices using sensor inputs, as I just mentioned, for adaptive learning. So while the robot is being used to run the experiments from the AI, and the robot's collecting data to send it back to the AI, at the same time, the AI can go out and get augmented information. In other words, it can decide what the next experiment is based upon the augmented information. So now what's happening is we're adding RAG to a real-time virtual to physical to virtual world. Now this thing becomes a super machine here. The next thing that happens is we start to develop real-time interfaces. So the physical prototypes will start to interact with the AI so that it can learn. But now imagine in that AI, the AI recognizes what's novel, and the AI can then help us figure out where the patents are in that process. Another thing is that there's a connection now between the mind and the body with AI. AI in the physical world kind of merge. So the AI virtually plans, say, a prosthetic limb. It can then 3D print it. It can then be physically tested, and then it can get virtualized wearer user feedback, which then can be used to change the prosthetic limb design again to 3D print again. And so there can be this very interesting world where it's not just AI data driving a physical robot where there's senses coming back. This could be an AI driving the CAD where the CAD actually is really printing things and the printing things are really being tested and the results are going back to the AI. So now AI is helping us create physical renditions. This thing then heads to all sorts of other places like simulated predicted outcomes, where AI can simulate and forecast physical results, predict failure points, and then guide the physical construction to overcome those failure points. So, for instance, supposing we're designing a bridge, we could take that bridge and put it in a wind tunnel virtually, and then use that to try to figure out where the risks are, and then overcome those risks with improvements to the design. Imagine if you want to, uh, you know, have the feedback train the AI model. So now we have the AI that's using a model to generate direction to the physical world. My device, the physical world is running, generating sensor data back to the AI. And I mentioned that it's improving itself. I didn't mention that it can supply its own corpus of information to augment itself. But now what could happen is through this process, it tests itself to create better models. So now just the notion of the AI developing output to a physical device, the physical device is running and coming back to the sensor data back to the AI. The AI is learning to develop a better model to try out. So now the model is changing, not just the AI is trying variations. The idea of digital twins becomes very interesting because now I could have a physical prototype and a digital prototype, twins, if you will, and they can test each other against each other. So this allows for enormous learning. You can then take things like having physical things that happen, like recipes and methods that you're trying out, and you can virtualize these recipe testings and create loops. So the AI can create sort of a cake recipe. The ingredients interact digitally. It can be digitally baked, if you will, for a digital version, and then that information comes back and could go to an AI-based digital tongue, and then the digital tongue would work, and then feedback data to the recipe, so the recipe can then be used to improve a final food product down the road. Being an ex-semiconductor engineer, we used to try to model all of these semiconductor processes. Now you can do the whole thing virtually and start building semiconductor fabs. They used to talk about a fabless semiconductor. Now it could be a virtual semiconductor fab, where most of the work gets done virtually before you even put, shovel to ground to build the fabricator. How about space? You can now get to the point where you can model things in space. AI creates the virtual space simulation. You can design physical explorations in the virtual space and get to the point that you're now understanding what will happen in space. And you're doing that right from your computer system. I was listening to a podcast the other day that Elon Musk is ready to produce 1,000 spaceships a year, 1,000 of these giant spaceships every year in his new city in Texas. He's building the same city in Florida and expects to launch 1,000 a year there. Between both of them, there's 2,000 spaceships a year. And these things are 4 or 5 times bigger than Boeing 747s or 777s. So he's producing all these spaceships because he really does intend to go to Mars. I mean, we're living in a world where these things are actually happening. We're living in a world where I have 6 AIs going to 25 AIs. So the stuff I'm talking about, uh, really isn't that crazy. I get excited that you can actually literally do space experiments by loading in your prototype into an engine and testing it in space. I don't even have to get in a spaceship, I guess, to go to Mars. And the next thing is, and I could go on and on for this, but business model viability is also a possibility here. You can use AI to virtualize a market to simulate if people will buy something, and then use the results as feedback to the sales to then improve whatever it is you're trying to selling as a business model. There's this process called SurveyMonkey, where you put a whole bunch of questions in, it goes to 1,000 people, and those answers help you design whether your product needs to be changed or whatever. Now you can do a virtual SurveyMonkey because you can literally build AI to build a consumer product, and you could test it against Facebook by just sending all this data and analyzing responses back by just looking at picking out responses from people to as if you sent the survey monkey up. You're just collecting data based upon the criteria by which you want, and now you've got a virtualized survey monkey. You can use that then to test a consumer product. So consumer products, space, recipes, digital twins, all these things. And and this is 2025, and we're about to head to 2026. And 2027 is when superintelligence may arrive, where all these AI agents are connected to each other. Quite the future. And so I was trying to create this part of the talk to talk about if that's all going to happen, where are we going to try to create patent value here? In the first 5 sections, I talked about patent value kind of through methods and strategies and examples, etc. But by doing this, we'll be ready for this future where patents may be one of the only things that you can use to stop others from using and selling your ideas. So let's wrap up. We talked about, don't patents always need to have prototypes? And I talked about dispelling that myth. I talked about the history in 1790 of the patent office and one of the buildings burning down. You didn't need working models, and the shift has happened over time. I talked about the difference between, say, chemical patents that might need a prototype, might need to show the examiner, but most cases don't. Software inventions that have now been allowed that allow people, many more people to be inventors. Talked about knowledge being something over 47 years old is where most inventors are because they know how to make things work. We talked about how some countries like Japan may have more requirements on evidence of operability, etc. But by thinking about that history, it helps us start to see the bigger picture because the future of AI, where the AI is going to actually enable these things, maybe the age of the inventor goes way, way down. Maybe countries change their laws. Maybe, maybe we will need the patent office to store our AI virtual models as files. Maybe the patent office will require that our inventions be checked out with an AI virtual model. We talked about topic number 2 about how instantaneous prototypes and lab work really can help us. And so we talked about things like rapid prototyping, how AI can give you quick iterations, how you can do virtual simulations, how you can have multimodal AI to help you with the examiner. We talked about how these AI agents are collaborating so that one AI calls another to run experiments so you can figure out what's novel in the data. We talked about how these advancements are all done at low cost. I talked about how I got 5 or 6 AIs right now, going to maybe 25 this year. So all of this is happening at almost low cost. So this instantaneous prototype and lab work is now firmly embedded in the patent system because people are using it today. We talked about a topic number 3. Where in the process do you do prototyping and experimental work in AI? Before or after or even during? We talked about how you could lower your risk by doing the prototype virtually so you don't waste the time waiting, like Alexander Graham Bell almost lost the ability to own Bell Telephone because he filed the patent an hour, I guess, at the right amount of time. We talked about claim breadth and how that could change. We talked about how you can add all sorts of experimental work to your specification for many continuations. We talked about looking at failures of your patent before you decide to build a product. We talked about how you can manage this whole best mode in trade secrets. We talked about how you can save money by having the AI prototype or lab work on the experiment first to make sure that the patent you file is going to be really valuable enough. And we certainly talked about how it boosts patent value, right? Go try to sell a patent or license a patent. If you have a prototype, there's a much higher probability. And we even talked about how you can use this to sort of confirm the cost effectiveness, how you can sort of verify that your product is going to work before you actually build it. In topic number 4, we gave you 10 different ways to add value. We talked about how images, can really help prove, the patent examiner this works. We talked about how data added to the specification can enable many continuations. We talked about how using the AI to find problems in your patent to inspire new prototypes and new claims. We talked about how you can use AI to create functional tests or how AI can give you testing claims. We even talked about how AI can help you with the examiner. Maybe you won't have a 101 rejection on abstractness by actually showing the examiner it works. There's so many ways that AI through prototyping and experimental lab work can help in the patent process. And every day we're discovering a new way to do that. In topic number 5, we talked about strategies for patents with enhanced prototype lab work. We talked about how it was so easy to sell provisionals with prototypes. We talked about how you could add continuations. We talked about how you could publish to attract partners. We even talked about how this helps startups. We talked about how it can help examiners by having multimodal results. We even talked about how the real world prototyping results enhance, integrating to get better patents. And finally, we talked about things like how you can lower the risk, or things like how you can scale, or even leveraging AI for simulations. And finally, in topic number 6, we talked about the future. We talked about this idea where truth is in the physical world, but now AI goes from the virtual to the physical back to the virtual. We talked about the whole reason for robots is to test the virtual world of these AIs. We talked about real-time AI interfaces. We talked about RAG, this augmented learning in a loop. We talked about the sort of the mind-body AI, where the physical world and the virtual world sort of come together, where I could literally print something from the AI to test it in the physical world. We talked about how simulations can predict things today that it couldn't do before and how there's enormous value there. We even talked about how you get feedback that trains the AI model itself, leaving this huge area of the future. This is such an exciting area when we start thinking about how AI is going to be used. When I'm talking about AI, I mean prototypes and experimental work in the patent process. So I hope you have enjoyed these different topics and the quick covering of them. And if you like, please subscribe and give us a thumbs up. And come listen to our series on inventors at work. This is John Cronin, Invent Anything.